Right, sorry for the interruption. Right. So relative to the inertia that we are of our rod that's connected to the motor, the inertia of the motor is quite insignificant, although I don't have the values for this uh, to make that judgment objectively. Uh, Based on what I know of the motor, I know that a rod of 0.5 kilograms and 0.2 meters in length would be extremely significant than whatever small inertias within the rod of this motor. So I'll keep it at these default values and of extremely small ones. And now the one thing which we haven't been able to find from the data sheet, this incomprehensive data sheet, is armature inductance. So I have looked at a large number of data sheets for 775 motors and its variants, and I was not able to find this out. So we'll resort to an kind of informal means of finding this. So that is to use this new tool. So I asked it to find out the armature inductance of the 775 Pro. For the first question, it was not available to answer it, and then I prompted it to find out a rough estimation based on the datasheets of other motors with similar specifications. So upon doing that, it gave me the recommendation of using an armature inductance of 5 microhenry to 30 microhenry. I don't know whether it has followed the exact instructions and actually considered other datasheets with similar specifications to this motor, but since I'm left with no other option, this is what I'll do. I'll take up ChatGPT's advice. So this is not to be your first try or your option of choice for figuring out the required characteristic parameters. In case that you have nothing else or no other resort, this is something that you can do, but it's not recommended. Right? Since the motor specification is done, I think we'll be able to run the simulation and see the results. At the moment, we won't be able to see the results since I don't have any scope blocks connected. So let me do that as well. Only Simulink signals can be connected to scopes, and if I were to connect this directly, then I would be seeing angles in radians. So just like in lecture 5, I can multiply it by the required constant in order to convert it to degrees first. But I saw that there's another block available in Simulink which does this for us. So it's radians to degrees, I think. It's quite a handy tool. I'll name it. I named it so that the name would pop up on the legend when viewing it. So that seems to be fine. I'll run it, and if I see any abnormalities, I'll come up and debug it on my own. At this stage, I don't see any issues, so I'll just quickly run the sim.